Hey guys, what's up? It's Eric with Advanced Level Automotive. Welcome back to another video. Today we're doing something a little bit different. We're going to be doing an engine rebuild. Right behind me I have a 2007 Chevrolet 1500 pickup truck. And it's got the 4.8 V8 Vortec engine in it. And the customer actually brought this vehicle in because it was smoking. And when I say it was smoking, I mean it was throwing clouds out of the tailpipe. So naturally we did our checks and we found out that this engine was burning oil to an excessive amount. Now of course we did check things like the PCV valve. We made sure that it wasn't stuck open. We also checked the valve stem seals, make sure that they weren't leaking into the cylinder. But this engine was burning oil continuously. When I say continuously, I mean you're driving down the road even after the engine's been running for 10 minutes and it's still blowing clouds of smoke out of the tailpipe. So naturally we came to the conclusion that it had to have a problem with the oiling rings and the pistons. So we went ahead and recommended to the customer to have the engine rebuilt. Now this engine does have over 340,000 miles on it. So it's no surprise that it's about time for this thing to get rebuilt. Now when I talked to the customer about it, he was actually really excited about the idea of having the engine rebuilt. He also told me that he was really thinking about swapping the 4.8 for a 5.3 engine. And we both agreed that right now would be the ideal opportunity to do that. So we went ahead and sourced him a 5.3 V8 Vortec engine out of a salvage yard. We had it brought over to the shop, and the plan is to disassemble that engine, inspect it, rebuild it, and then put that engine into this truck. So we're gonna be breaking up this video into different parts. Today we're gonna be doing the disassembly and inspection of the engine, because like I said, this engine's coming from a salvage yard. So when we tear it down, we're gonna need to inspect it to make sure that we don't have any internal engine damage. Hopefully not. Hopefully the engine just has normal wear and we can do a basic rebuild and not have to worry about oversizing the cylinder bores or having to have the crankshaft machined. So anyways, hopefully you guys stay tuned for the video. Let's go ahead and get started. Today we have a Vortec engine, 5.3 out of a Chevy pickup truck. We're gonna start the tear down, disassembly. We're gonna do the inspection, then we're gonna do the rebuild. This engine came out of a salvage yard, so it's really important that when we disassemble this, we're going to inspect every part of it. We're going to inspect the rotating assembly, the cylinder walls, we're going to inspect the valve train, we're gonna see what needs to get taken to the machine shop to have machine work done, and we're gonna see what we can and cannot reuse. So let's go ahead and start with the disassembly. And whenever you remove these valve covers, this is a used engine out of a salvage yard, so you want to inspect for things like rust, sludge, any type of mechanical damage in the engine. If you look here, we do have some slight rust on these rocker arms, so we may or may not be able to clean these up. We're going to have to put these in the parts washer, clean them up, make sure that they get lubed up properly. I don't see any broken valve springs. The valve springs look okay, so there's no issues mechanically here. Let's go ahead and pull the other cover off. All right, so now that we have this valve cover off, we can do the same thing on this side. We'll inspect the rocker arms, we'll inspect the valve springs, we'll inspect the valve train, make sure we don't have any broken pieces, make sure there's no excessive rust, make sure there's no excessive engine sludge buildup. Over here, we look pretty good, so let's go ahead and start disassembling the valve train. Now we're just gonna lift up on this assembly, like so, and we're gonna lay it down on the table. Now we're going to take our box, we've got our box here. I'm going to go ahead and start pulling these push rods out and just stick them in the hole. And as we're pulling them out, we're just going to kind of inspect these. We're going to look for wear on the tip of these push rods. Any excessive wear, we want to make sure that they're nice and round and that they're not bent. So as we pull these out, we're just going to be inspecting them. And let's go ahead and do the same for the other side. I've already got this unbolted. Let's go ahead and lift up on this. Set it aside next to the other one. Like so. And then we'll start pulling these push rods out and inspecting them. So you can see this one's pretty rusty. This engine looks like it sat out in the rain. That, or we may have had water in the oil at some point. Possible that we could have had a blown head gasket and had water in the engine oil, because when we did drain the oil, whatever was left of it, it was pretty milkshakey. So Did not look very good. The only thing I really see is the excessive rust on these. Alright, so like I said, so far everything looks okay. There is no catastrophic failure or any severely damaged parts in the valve train. Like I did mention, when we first drained, whatever oil was left in the oil pan, it did look a little milkshaky, as if water was in the engine. So we're going to keep that in the back of our mind as we continue to disassemble this. Alright, so next up we're going to remove this valley cover. It's got these 10mm bolts. Let's go ahead and remove them. Set these bolts aside. Remember, as you're taking the engine apart, make sure that you have a bin to put these bolts in and label that bin so that you know where they go. So I'll go ahead and throw them in here. We've already removed the knock sensors that were down in these holes. So let's go ahead and take a screwdriver and pry up on this cover. You do have to fight the grommets that are in here, so you got to give it a little bit of muscle, but we'll see, it will come up. And now that we got it up, we can go ahead and remove this cover. We'll set the cover aside. Alright guys, so now we can move on to removing the cylinder heads. We need to go ahead and remove these 10 15mm bolts. There's 5 up here and there's 5 down here, and then we need to remove these 5 10mm bolts. We're going to do this in a cross pattern, starting from the center out. So we're going to go like this: 1 2 3 4 5 6 7 8 9 10, and then we're going to remove these top ones. Looking at these cylinder heads, we're not going to be able to fully inspect them until we get them really cleaned up, but we just want to look for any obvious signs of cracks, any signs of fissures, any signs of valve wear, or any signs of valve seating issues. If we look at these valves, you can see they're nicely seated in the head. If we notice any valve that's not seated properly, we'll know that we have a valve seating issue. Or if you see any valves that are cracked, any damage, we just want to do a preliminary inspection of the cylinder head. Once we get the surface cleaned up, we'll be able to get a better look at it, but so far both of these heads look pretty good. Alright guys, so over here we have one of the cylinder heads. We've already cleaned off the surface just using a Scotch-Brite pad to get most of the gasket material off, just by lightly scuffing it. Anyways, what we're going to be checking for is cylinder head warpage, and the way we're going to do that is we're going to be using a straight edge. So I got a straight edge right here, and we're going to be taking 3 different measurements. We're going to be taking one across the center like this. We're going to be taking one up here. We're going to be taking another one down here. We're going to be using a feeler gauge to check this. So let me go ahead and show you how we're going to do that. We're going to start right there in the center. And the spec for this is that GM wants to see no more than 0.04 of an inch of warpage across the cylinder head. But I really don't want to see any more than 0.03. So we have a 0.03 feeler gauge right here. These are pretty thin. And what we're going to want to do is just kind of go to each surface right here, each part of the surface, and we're going to see if we can slide the feeler gauge through. So you can see right here it does not slide through. We're going to try it over here. Doesn't want to go through. We'll try it over here. Does not want to go through. We'll try it over here. Same thing. Over here. Same thing. Now if we found a spot, let's say right here where the feeler gauge went through, then we know that this part right here is actually lower than the rest of it. So that's going to indicate whether or not we have warpage. Looks good right here. So let's go ahead and take another measurement up here. Again, we're just going to take our feeler gauge. We're going to try to see if we can pass through the straight edge. As you can see, that's looking pretty good. We'll go ahead and move over here. As you can see, the cylinder head looks pretty good. All right guys, so now that we have the cylinder heads off, we can get a closer inspection at the head gasket and also the cylinders. So first thing I like to do is look at the head gasket and see if there was any signs of head gasket failure. I like to look around these compression rings to see if there was any spots where it looks like it may have had some leakage into the combustion chamber. If you look around here, I don't really see any signs of a blown head gasket, but I can tell you this, looking at these water jackets, I can tell that there was a lot of corrosion. They may have just been running straight water for quite some time, on this engine because there's a pretty good amount of corrosion on the head gasket and in the cooling jacket. So show you that. Let's go to the other side and take a look. All right, looking at the head gasket once again, you'll see these compression rings. I don't really see any indication of a blown head gasket on these compression rings. They all look pretty normal, but again, these water jackets have corrosion, especially this one. I don't know if you can see that, but that's actually raised up. That's interesting. Anyways, you'll see the amount of corrosion. So it does look like this cooling system was running straight water for some time. The other indication of a blown head gasket would be pistons that are steam cleaned. You'll notice that these pistons are nice and black, but we don't see any that are like shiny and clean. If it had water in the cylinder, you would have a nice clean piston. So I don't see any of that. These pistons all look black. They all look uniform. So the other thing we can look at while we have the cylinder head off is we can look at the cylinder walls. So we want to inspect the cylinder walls to see if there's any gouging, any deep scratches. Looking at these cylinder walls so far, I mean, I really can't look at these pistons that are up until we spin the engine over, but so far they look okay. The other thing you can look for is for a ridge on the end of the cylinder here. If there is a ridge, then this is going to need to be ridge reamed. So looking at the other side, cylinder walls look okay. I don't see any excessive gashes or scratches. There isn't an excessive ridge on the end of the cylinder here. At the top of the cylinder, I mean. Cylinder walls look okay. A little bit dirty here, but not really scratched. All right, so next up, we're going to remove these lifter carriages so we can inspect the lifters. These are the lifter trays. See if we can get these lifters to come out with it. Got some pliers. We're going to go ahead and pull these lifters out. And what we want to do is, as we're pulling these lifters out, we want to inspect the rollers, look for excessive play in the roller, and also look for any scratches or gouges on the roller surface. Also, you want to check to see if this plunger is collapsed. For the rebuild, we're going to replace these anyways, but pulling them out and inspecting it is going to give us an indication of how the engine was maintained and if there's any damage to the camshaft. So let's pull the rest of these out. All right, now we're going to do the same to the other side. All right, guys, so we don't see any excessive wear on these lifters. That's a good thing because that's an indication that our camshaft is probably reusable. So let's go ahead and continue with the disassembly. Next up, we're going to go ahead and remove the crank pulley, and we're going to remove the timing cover. All right, so next up, we're going to pull the crank pulley off. We've got a 24mm socket. Let's see if we can bust this bolt off. All right, so now that we got the bolt off, we're going to use a puller to remove the pulley. All right, so next up, we're removing the timing cover bolts so that we can remove the timing cover. All right, now that we have the timing cover off, we can closely inspect the timing chain. We can look for excessive play, excessive looseness, but we're going to be replacing this chain anyway, so it's not going to matter. Next up, let's pull the oil pump off and take a look at it. All right, so before we can fully remove this oil pump, we're going to need to flip the engine over and remove the oil pan. All right, so on the back side of this engine, there is a rear main seal plate. We've already removed this. We removed it before we actually put the engine on the engine stand. You're going to want to do that because it's going to be very difficult to remove it while the engine is on the engine stand. So now let's go ahead and pull the oil pan bolts off. All right, so now that we have the bolts off, let's go ahead and lift up on the oil pan. All right, and as you can see, this is what I was talking about. We had a little bit of a milkshake going on inside the oil. When we went to drain whatever oil was left inside the engine, it came out like this. This is milky. This is an indication that we had water getting into this engine. I don't know if this is from some type of coolant leak inside the engine, or maybe this engine just sat out in the rain and that's why we have this milkshake happening. So let's continue to disassemble this. Let's get a closer look at the rotating assembly. All right, so next up, let's pull off this sump tube. And we have a 10mm bolt here. One more nut here. Now let's lift up on this. Got the sump tube off, let's set it aside. Now we can pull the oil pump off. And if we're curious, we can open this up and inspect the inside of it. All right, so let's go ahead and pull this plate off. All right, this is a vane type oil pump. And what that means is we're gonna have these two gears, and as the pump is rotating, this is going to be compressing the oil and shooting it out of the other side. So that's how the oil pressure is built up. What we're gonna wanna do is take a close look at these vane gears. We wanna look for any excessive gashes, any scratching, any gouges. But so far these look pretty good. I'm gonna try to pull this out. It's kind of stuck in there. All right, so looking at this gear, we don't see any excessive gouges or scratches. And looking at this gear, it looks pretty good too. Also, we'll take a look at the case. The inside of it, we want to see for any excessive scratches or gouges. This looks pretty good, just normal wear. Also on the cover plate, we want to look for the same thing. Which in this case, it looks pretty good. I don't see any excessive wear on this pump, just normal. Let's go ahead and set it to the side. We're going to be replacing this anyway. We're going to go ahead and remove the timing chain. We'll just set that aside. Got the bolts removed for the cam plate. We're going to go ahead and pull this off. Inspect the little gasket on there. Next up, we're going to go ahead and pull this camshaft off. Quick tip, we'll put the cam bolts back in here and use them as a handle to pull these out. Right. So now we're going to go ahead and pull on the camshaft. Try to keep it centered as we pull it out. And then we're going to want to closely inspect the camshaft lobes. We want to look for any gouges, any scratches. We want to look for any lips that have been created from the rollers. So we just kind of look down the camshaft, take a look at all these lobes and then these journals right here. All right, so far this camshaft feels good. We're gonna go ahead and clean it up. All right, so next up, we're gonna wanna remove the connecting rods. In order for us to be able to do that, we're gonna need to be able to turn the rotating assembly. So I'm gonna stick the crank bolt back in here. We're gonna screw it back in and we're gonna use it to turn the engine. All right, so now we can start removing these connecting rod cap. All right, so the way that we're gonna remove these connecting rods is we're going to spin the engine over till we get these connecting rods up at the top. That gives us access to these bolts so that we can remove the caps and then pull the pistons out. When we remove the pistons, we're gonna go ahead and lay them on the table in order. So this is gonna go from front to back, 1, 2, 3, 4, 5, 6, 7, 8. So let's go ahead and start with number 1, which is the very front one. We're gonna remove the 2 bolts, remove the cap. When we do that, we're going to inspect the bearings. Again, we wanna look for any gouges, any scratches, or any discoloration. In this case, this actually looks pretty good. So let's go ahead and push down on the piston. And now we can go ahead and push the piston from the top side, and it's gonna come out through the bottom side over here. So I'm gonna push the connecting rod down, and we're gonna push the piston out of the hole. Just like that. We have the table marked and labeled 1, 2, 3, 4, 5, 6, 7, 8. This is number 1. Before we put this down and move on to the next one, we're going to want to just inspect the piston rings. Look for any cracks, any cracked piston rings, any frozen oil rings. These pistons look pretty good. We're going to go ahead and clean them up. Let's move on to the next ones. All right, so now that we have the pistons removed, we can take a look at the crank journals for the rods. Again, we're going to want to look for any deep gouges, any scratches, any discoloration, because that is going to indicate whether or not we're going to need to send this crank off to the machine shop to get resurfaced or grinded down. In this case, these journals look pretty good. I think we can just send this crank off to get polished and we'll be just fine. All right, so next up, we're going to want to remove the crankshaft. In order to do that, we're going to need to remove these main caps. These main caps have 6 bolts. We have 2 10mm bolts on the side, and we have these 4 15mm bolts at the top. So let's go ahead and start removing these main caps. Now we can pry these main caps off. All right, so just a quick tip. We've already got these main caps off, but they do make a special tool to remove these, but it's pretty simple. If you have 2 people or at least 2 pry bars, you can just stick a pry bar in here and have somebody stick another pry bar on this side, and you guys both pry them up at the same time, and these caps will come right off. So now that we have them all off, remember, keep these in order. Next up, let's go ahead and inspect the crankshaft. All right, so now that we have those main caps off, we can closely inspect the main journals. We want to look again for any pitting, any deep gashes, any scratches. And so far, all of these journals look really good. This crankshaft does not need to be machined. We can go ahead and have this thing polished. Let's go ahead and lift it up out of the block assembly and get this over to the table. We pretty much have a bare block. Again, we've already inspected the mains. These are the bottom half of the main bearings. They look pretty good. So to be honest with you, I think this engine was in pretty good shape. So next up, let's go ahead and look deep into the block. You'll see the cam bearings in the cam journal. What we want to do is we want to take a look. We want to see if there's any excessive pitting, any scratches. Again, we're looking for anything that's excessive. We are going to replace these anyways, but we just wanted to check on the condition and how this engine was treated. All right, guys, so now that we have a bare block, we can now continue to the next step, which is measuring the cylinder bore diameter. When we measure the cylinder bore diameter, we're looking for 3 different things. We're looking for taper, we're looking for out of round, and we're looking for oversize. These 3 factors are going to dictate whether or not we need to send this block to the machine shop to get the cylinders overbore. Overboring the cylinders are going to require us to use an oversized piston. Let me explain this in a little more detail. All right, guys, so just to give you a better visual of what it is we're looking for when we're measuring the cylinder bore, again, we're looking for 3 different things. We're looking for taper, we're looking for out of round, and we're looking for oversize. I went ahead and drew this up on a piece of paper just to make it easier to understand. But if you look here, we're looking at a side view of the cylinder bore, and over here we're looking at top views of the cylinder bore. Okay, so first off, when we're talking about taper, we're talking about a taper along the cylinder bore walls. So what that means is that it is possible that over time the cylinder walls can wear in a way that some parts of the cylinder walls are actually larger than others. So let's say you could have a larger bore at the top than at the bottom, and that's just because the way the cylinder wall has worn over time. So that's one of the important things that we need to check. The cylinder must be perfectly straight. If there's a taper on the cylinder walls, then we're going to need to have the machine shop overbore the cylinder. Next up is out of round. Again, we're looking at this from the top view, and what we mean by out of round is that it is possible that the hole or the bore is no longer a perfect circle the way it needs to be. It should be a perfect round circle. So when we measure the cylinder bore, we should find the same measurement all the way around. If we find that the hole has become oblong or oval, then this is going to need to be sent to the machine shop so they can overbore the cylinder. Okay, next up is oversize, and by oversize what we mean is that the cylinder bore itself has become larger than the specified diameter. If the cylinder bore becomes too large, then there's going to be too much clearance between the piston and the cylinder wall. Too much of a gap between the piston and the cylinder wall can cause an excessive gap in the piston ring. Excessive gap in the piston ring can lead to compression issues, can also lead to excessive oil consumption. So if we have an oversized cylinder, we're going to need to send this to the machine shop. It's going to have to be overboard, which means we're going to have to use an oversized piston. So hopefully that makes sense to you guys. So let me show you how we're going to do it. Okay, so over here we have a bore dial gauge, and this is simply a dial gauge that we are going to use to put down into the cylinder bore so that we can measure it. And essentially, in order to use this tool, we're going to pick the right size that we need, and then we're going to set the tool. We're going to zero it out. I'll show you how to do that in a second. First, let me show you what we're going to measure. All right, guys, so moving over to this illustration, I just want to show you where we're going to be taking our measurements. So if you look over here, you'll see the top view of the cylinder, and then over here, you'll see the side view of the cylinder bore. Now, there's a lot of different measurements that we can take, but mainly what we want to do is we want to compare what we call the thrust side of the cylinder wall versus the non-thrust side. And what I mean by that is the thrust side of the cylinder wall is going to be the part of the cylinder wall that gets most of the wear. And the reason for that is because as the piston is rotating on the crankshaft, it naturally digs into the vertical part of the cylinder wall, not so much the horizontal part. So what happens over time is that you'll have more wear on the thrust side of the cylinder wall than you will the non-thrust side of the cylinder wall. So we need to take our measurements here and here so that we can compare the two. Now when we do our measurements, we're also going to be taking our measurements in 3 different places along the cylinder wall. So we're going to start here at the top, and we're going to do our 2 measurements, and then we're going to move somewhere toward the center where we're going to do our measurements again, and then we're going to move toward the bottom. Now we don't want to go too far down into the cylinder bore because this is the area that the piston does not travel in. So we don't really want to take any measurements here. We just want to kind of take 3 different measurements in the area that the piston does travel. So let's go ahead and do that. All right, guys, so just to reiterate on what I mean by thrust side of the cylinder wall, I found this illustration online, and it does a pretty good job of explaining what I mean. So as you see, as the crankshaft is rotating, the piston is naturally going to be pushing up against the side of the cylinder wall that's on axis with the crankshaft. And you'll see as it's coming up, it's pushing more on this side, and when it's coming down, it's pushing on this side. So hopefully that visual makes sense. Now let's move on. All right, guys, so moving over to the computer, I've got the engine specifications pulled up here. And the first thing we're going to look at is the cylinder bore diameter. I've got it highlighted right here. And if you follow it over, you'll see that the specification is somewhere between 3.779 inches and 3.78 inches. So what we're going to want to do is set our measurement tool somewhere between this specification here. Now the measuring tool that we're using today is going to be these digital calipers. I've already got this zeroed out, and I have made sure that it's properly calibrated. One of the things that you can do if you're not sure if your calibration is on is take a feeler gauge. Right here I have a 30 thousandths feeler gauge. Let's see here, we've got a 30 thousandths feeler gauge. I'm going to go ahead and use the calipers to measure this feeler gauge. All right, so as you can see, I've got my feeler gauge in the caliper here, and I've got it clamped down. So as you can see, we're spot on as far as the calibration goes. We're looking at 30 thousandths of an inch. So let's go ahead and set this to the cylinder bore diameter. All right, so as you can see, I've got this thing set to 3.7795, which is within the specification. And what we're going to use this tool for is to zero out the bore dial gauge. Now this bore dial gauge has a bottom needle right here that we've already pre-assembled. We've chosen the correct length for the needle, and we're simply going to stick it in between here, and we're going to rock it back and forth, and we're going to zero out the needle. I'll show you how to do that in a second. But one quick important note about this bore dial gauge is that it reads in increments of thousands. So if you see 0 and you'll see 5 right here, 5 means 5 thousandths, 10 means 10 thousandths, the 15 means 15 thousandths, and so on and so forth. All right, guys, so moving over to the workbench over here, I've got the digital calipers on the vise. So you can see we have it set to the bore size. So we're going to use that to zero out this bore dial gauge. Let me show you how we're going to do that. We're going to stick this part of it in between here, and we're going to rock it back and forth. When we rock it back and forth, we're going to be watching the needle on this gauge right here. And what we're going to try to do is get the smallest point to be the 0. So let's go ahead and do that. All right, so we're going to take this bottom part, and we're going to stick it in the calipers. Now we're going to rock it back and forth. Pay attention to the gauge. I'm rocking it back and forth. As you can see where the lowest point is, we're going to try to move the 0 to that lowest point, which is right about there. Let me move the gauge over, spin this dial here. Now let me try to rock it back and forth again. As you can see, the lowest point is the 0. We are now set. All right, guys, so before I continue, I just want to address one little thing, because I know I'm going to get some flack about it, especially in the comment section, and it's going to be from people who are saying, why aren't you using a micrometer? Everyone else uses a micrometer. You should be using a micrometer. The reason I like to use the digital caliper setup is because, number one, I know I've calibrated this thing and the measurements are spot on. Second is because with the micrometer, you only have a small tip. On these digital calipers, you have a nice wide surface here, a wide and long surface to rock the bore gauge back and forth in order to do the measurements. When you're using a micrometer, you only have these little tips, these points, and it's very difficult to be able to rock back and forth the bore dial gauge in order to zero it out properly. So if you ask me, I'd much rather use this tool because we have a nice wide and long surface here on both ends, and these are truly flat, so that we can rock the bore dial gauge back and forth so that we can get our proper measurement. Okay, so before doing any measurements, you need to make sure that you wipe down the cylinder walls nice and clean. You can use something like brake clean or carb clean to make sure we don't have any residue on the cylinder walls. These cylinder walls, I've already gone through and cleaned them up. They look pretty good. Again, we don't have any gashes or any deep scratches, so hopefully the measurements check out. All right, so we're gonna start with the first cylinder on this side. I'm gonna go ahead and stick the bore dial gauge in here. Like I said, we're gonna measure at the top, and all I'm gonna do is I'm gonna rock it back and forth like this. And what we're looking for is the lowest point on this gauge. So we take a look at the gauge. You can see I'm rocking it back and forth. And we're right around the 0. At the lowest point, you can see where that's at. Now I'm gonna go down a little bit further into the bore, somewhere in the center. Let's do the same thing. You can see where the measurement is. Now let's go a little bit further down. So as far as taper going this way, it looks pretty good. Let's go ahead and flip this vertically this way. I'm gonna go ahead and put this in. Now we're gonna measure the top of the cylinder. I'm rocking it back and forth. As you can see, the lowest point is a little bit right above the 0. So there is a very minimal amount of taper here. Let's go a little bit further down into the bore. Let's go a little further down. And we're still really close to the 0, and that's looking pretty good. Let's go ahead and check the rest of the cylinders. All right, so moving on to the next cylinder, we're gonna do the same thing horizontally. We're going to measure it up at the top of the cylinder bore. Let's rock it back and forth. As you can see, its lowest point is right about there, a little bit below the 0. Let's move it a little bit down to the center of the bore. Rock it back and forth. So you can see its lowest point right about there. Let's move further down, rock it back and forth, and you can see its lowest point right about there. Let's go ahead and measure it vertically. We are at the top of the cylinder. Let's rock it back and forth. So you can see its lowest point is right around the 0, or a little bit below it. Let's go a little bit further down. A little bit further down into the bore. Let's rock it back and forth. It's looking about the same. Let's go a little bit further down into the cylinder. Rock it back and forth. And it's looking about the same. So I'm going to go ahead and measure the rest of the cylinders. Alright guys, so after doing our cylinder bore measurements, we found that we were pretty much within a thousandth of an inch. So I don't think we need to go oversized. Everything looks pretty good. We're gonna go ahead and send the block off to the machine shop. We're gonna have them clean and inspect it, double check my measurements, and then we're also gonna have them install the cam bearings, which is something that I don't like doing. It's a real pain in the butt, so I'm just gonna let them handle that part. Anyways, guys, thank you for watching the video. Hopefully you found it useful. Hopefully you found it informational. If you did, please make sure to hit the like button. If you enjoy the channel, please make sure you subscribe to the channel. If you have any questions, you can always comment down below, and I hope to see you guys in the next one. Thanks.